Okay, so today we are going to cover section 1.8, and in this lesson we're going to see absolute value equations and absolute value inequalities. Now, before we begin, let's just review what it means to find the absolute value of a number. So, for example, let me add a little blank page here. If I said, let's find the absolute value of 12, everybody remember what absolute value means? It means that it's the distance the number is from 0. So, and also remember that when you find the absolute value of a number, it's a distance, so it's always positive. So when you find the absolute value of 12, it's positive 12. When you find the absolute value of negative 12, it's 12. Now, let's say I had an equation here, and I said, if the absolute value of x equals 5, what numbers could I put in there for x to get a 5 as an answer? Good. So notice you could put in a 5 and negative 5, and they will both give you 5 as your result. So having understood this, this is going to help us understand the process for solving these. Because when we go to solve these, we're going to make two problems. So let's try our first example. Now, I know my absolute value bars here look like part of the number, but these are the bars. So it's 5 minus 3x in absolute value bars. So your step number 1 for solving absolute value equations is to isolate the absolute value. So your first step is to make sure that what's in the absolute value bars is on one side of the equal sign. So it's already done for me. So now what I'm going to do is set up my two problems that I'm going to solve. And I have to take into consideration that one can be positive, one's negative. So the two equations I'm going to use to solve are going to be 5 minus 3x equals 12. And then the other problem, or the other case that I set up to get my value of x, is going to be 5 minus 3x equals negative 12. So what's in the absolute value bar stays exactly the same. What I'm changing is what it equals. The first time I rewrite the problem the same way, I just take away the bars. The second time I change the answer and make it negative. I now need to solve each equation for x. So I'm going to subtract 5 from both sides. And I get negative 3x equals 7. I'm going to divide by negative 3. And I get x equals negative 7/3. Now I'm going to repeat the process for the right side. Subtract 5. I get negative 3x equals negative 17. Divide by negative 3. And then a negative divided by a negative is positive 17/3. You do not need to make them mixed numbers. You can leave them improper. So if this were a question on your test, you can either leave it with x equals, or you can also put it in the set brackets here. And those are, so you can write it as negative 7/3 and then 17/3 with the set brackets. Now, what would you think you would get if I have this instead initially? 5 minus 3x equals negative 12. What do you think I need to do on a situation like that? Now, notice we made the two problems, but remember, when I made my two problems, they don't have absolute value bars anymore. But this one does. Can I ever get a negative number out of an absolute value? Okay, so whenever you get a problem like this, your answer is going to be no solution. Because it's not going to matter what x is, I will never get this thing to equal negative 12. So whenever you see that your equation or your inequality is set equal or less than or equal to or greater than or equal to a negative number, you need to stop and think. Don't even try to make your two problems. So as soon as you see it's an equal sign to a negative number, the answer is no solution. And in the coming examples, we'll see the inequality ones, what happens with those. Let's try example 2. Again, step number 1, isolate the absolute value. And it's already isolated. It's the only thing on the left side. So now what I need to do is set up my two problems. So I'm going to rewrite the whole thing. Just take away the absolute value bars. Same symbol. And it's 7. Now, just like before with the equal sign, I'm going to change the sign on the 7. But in addition to that, I'm also going to reverse my inequality symbol. So I'm going to actually do 2x plus 1 is greater than negative 7. So in addition to negating or making it negative, you're also going to reverse the symbol. And now I'm going to solve these two problems. Now, just like we saw before, our answers are going to be written in interval notation when it's an inequality. So here I'm going to subtract 1. 2x equals, no, not equals, is less than 6. Divide by 2. And x is less than 3. I need to repeat and solve the right side. So subtract 1. 2 is greater than negative 8. Divide by 2. And x is greater than negative 4. Now, I need to write this in interval notation so I can either do the test point or I can graph this. So you can do it either way. So if you want to just stay consistent and do it, solve it the same way that you did the quadratics, you can do that in the same way you did the other one. So for example, what you're going to do is you can make your number line so you can make your intervals. This is one way to get your interval notation. And it's going to appear in a minute. Again, I'm going to locate where 0 is in my number line. And then I'm going to plug it into the original. And it will catch up here momentarily. So I've drawn my number line and broken my intervals up. I can see, and this should be a positive 3, I can see that 0 is going to be located here in the middle. So when I plug it in, if I get a true statement, I put a check mark. If I don't get a true statement, I put an X. So 2 times 0 plus 1, still in the bars, is 2 times 0 is 0, plus 1 is 1. Absolute value of 1 is 1. Is 7 greater than 1, or is 1 less than 7? Yes, it is. So you put the check mark in the middle. The ends would get X's. So in interval notation, you're going to write it with parentheses because it was just a less than symbol. And there's your answer. This is the answer I want to see. Now, the other way you can come up with your interval notation is you could graph them. So what you could also do is create a number line. And this is probably what you did in Algebra 1. Put the numbers on the number line. Okay, so I'm going to put my numbers on my number line, and I'm going to graph each one individually. So this one here, x is less than 3, would be an open circle on 3 going to this direction. Then this one, when I graph it, x is greater than -4, going that way. And you can see that it's a segment, and that would be like the intersection. So you would just write the two numbers. So you can also graph it. I know we were more familiar with this method either way. Now, if the arrows go out, then if your graph looked like this, where this one went this way and this one went this way, that's when we're going to use the union. All right, everybody good on that one? Let's try number 3. I'm going to reverse the symbol. So now, instead of less than, now I have my inequality greater than 7. But again, my process is the same. I'm going to write my first problem, 2x plus 1 greater than 7, then 2x plus 1 less than negative 7. And again, I need to solve. So subtract. 2x is greater than 6. Divide by 2. X is greater than 3. Subtract 1. 2x less than negative 8. Divide by 2. X is less than negative 4. So again, you can do your test point. Put your numbers on here, least to greatest. Locate 0. Again, 0 is in the middle. So again, I can plug it in. So 2 times 0 plus 1. Is that greater than 7? Is 1 greater than 7? No, it's not. So this gets an X. This gets the checks. So when the ends get the check, then it's the union. So we're going to do negative infinity up to the negative 4. And remember, your original symbol was just a greater than. So parentheses, unioned with 3 up to infinity. And this is how I want to see the answer. Now, if you graphed it, this would have been with the arrows pointing outward. Negative 4, 3. So if I graph this one, x is greater than 3, going that way. And then when I graph x is less than negative 4, going that way. So it's either the left yellow or the green right. Next one, still the same idea. The only difference here is I've got a number that's outside my absolute value that's over here on the left side. So again, remember, step 1 is to get that 2 minus 7x to be all by itself. So the first thing I'm going to do here is add the 1. Now the 2 minus 7x is all by itself, and now I can make my 2 problems. If you jump to making your 2 problems without isolating, you're going to get the wrong answer. So you need to isolate the absolute value first. So then I set the first problem, and then take away the bars. Here, 2 minus 7x, flip it, and make it negative 5. And now I begin my solving process by subtracting 2. And get 3, and then divide by negative 7. Be careful, we're dividing by a negative, so we need to remember to reverse or flip this thing. And then a positive divided by a negative is a negative 3 over 7. Over here, solve this one. I'm still going to divide by a negative, so again I'm going to reverse. And it becomes negative divided by a negative is a positive 1. And now again, you can do your test point or graph it, however method you want to use in order to come up with your interval notation. So if I did the test point, negative 3/7 here, positive 1 here. I see my 0 is located in the middle. I'm going to go ahead and plug it in. So I get 2 minus 7 times 0 in the bars, minus 1 greater than 4. So 2 minus 0 is 2, absolute valued. Minus 1 is 1 greater than 4. No, it is not. This fails, so this gets an X. Then the check marks are here. So again, I can see that this is a union. You can also graph it. If you graph it, this one would be open this way, going here, and then this one open, going this way. So the interval notation, negative infinity up to negative 3 over 7, and it's all parentheses because it's just a greater than symbol, and then here 1 up to infinity. again, once your absolute value is isolated and you see a negative number over here, this should be a clue for you to stop and think. If it's an equal sign, it's no solution. If it's a greater than sign, we know all numbers are going to be greater than negative, will be positive. So this is going to represent all real numbers. And you will write this in interval notation from negative infinity to positive infinity. So when it's greater than a negative number, it's all real numbers. But when it's less than a negative number, it will be no solution. And that's going to be the next example. So again, I want to see it written in interval notation. So from negative infinity to positive infinity.
Brackets?
No.
No way.
Yeah, there's parentheses.
Yeah, okay.
Always around infinity is parentheses.
Oh, that's right.
Okay. Yeah, let me erase the circle here. So always around infinity are parentheses, no brackets ever around infinities. And then here, notice it's less than a negative number. Less than a negative number tells me what's coming out of here is going to try to be negative, and it will never happen. So it's no solution, and that's how you write it in interval notation. It's just the circle with a slash. Yes?
I didn't see, was there parentheses? I mean,
When it's less than a negative number, it is no solution. The last examples are going to be dealing when it's set equal or greater than or less than to 0. So number 7, remember the steps. Isolate the absolute value. It's already isolated, so now I make my two problems. However, when we're setting up our problems, we don't have a positive and a negative 0. So whenever it's equal to 0, there's only going to be one answer. We're not going to set it equal to positive 0 and then the other one to negative 0, because 0 is 0. So then here I'm just going to solve by subtracting 15. And then divide by 5. And I get x equals negative 3. And again, when it's equal, you can either write x equals or put the answer in the set braces. So that's when it equals 0. The next example is when it's going to be less than or equal to 0. Now, if it's less than 0, we already know it's no solution. Everybody with me on that? So let's say I just modified this one problem here. So let's say I have 5x plus 15 less than 0. I know numbers that are less than 0 are negative. So when it's just a plain less than, no solution. But the next example actually has less than or equal to. So I need to take into consideration the equal to part of this symbol. So what I'm going to do is I'm going to set 3x plus 2 equals 0 and solve. Because this is only going to be the answer that works. There aren't any numbers that are less than 0 that work. So 3x equals negative 2. Divide by 3. And x equals negative 2/3. Yes.
And there's no way to put that into interval notation.
Correct. Yep, no interval notation on this one. And this one is when it's greater than 0. So here, we might start to think, wait a minute, anything greater than 0 is positive. So potentially this could be all real numbers. However, notice we do not have an or equal to. So in this case, the number that equals 0 would not satisfy that, because we would get 0 is greater than 0, which isn't true. And let me show you what I mean by that. So technically, if this were greater than or equal to, it would just be all real numbers. However, because it doesn't have the or equal to part, there's going to be one specific point that is going to be excluded from the all real numbers. So let me erase this. So here, I'm going to know that the value I need to exclude is when 4x plus 3 equals 0. And the way I'm going to find out what x cannot be is solve this. So 4x equals -3, divide by 4, and x cannot equal -3/4. Because watch what happens when I plug it in. 4 times -3/4 plus 3 and then I check to see if it's greater than 0. Notice here I'm going to get -3 plus 3 and I get 0. 0 is not greater than 0, it's equal to 0. So this would be the only time out of the whole number line that this inequality would not be true. Other than that, any number that you put in there will result in a positive answer, and it would be all real numbers. The way that you're going to write it for the intersection, or for the union, sorry, because if you think about it on the number line, it's going to be the entire number line except where -3/4 is. So there's going to be like a hole here because it's going to be just a greater than symbol, and then everything to this side and everything to this side. And the way that you'll write it in interval notation will be from -infinity up to the -3/4, union with -3/4 to positive infinity. And what these parentheses indicate is that once you hit the 3/4, it can't include it. It's just like a stopping point, and then the other side is the starting point. So be careful when it's a negative number on one side and the zeros. Those are going to be the special situations. So your homework is pages 164 to 165. You're doing 9 through 15 odd, and then starting at 27, every other odd. Now I know it says to go to 61, but I think the last every other odd might be 59. But again, if you find that you're struggling and you need more practice problems, do all of the odds because you have the answers to all of the odds. And this would be a good way for you to study for the test. So on Monday, so this is homework due Monday. On Monday, we will review for your test, and your test is Tuesday.